Hello and welcome to today's lesson. In today's lesson, we are going to learn about coordinate, which is also known as dative bonding. So what is coordinate or dative bonding? We say this is a type of covalent bonding where electrons in the shared pair come from the same atom. So what happens in this type of bonding is that a pair of electrons, which is referred to as lone pair, is donated by one atom. So in this type of bonding, we have a donor atom and we have an acceptor. We have an acceptor atom. So a pair of two electrons will be shared. Now, what is so important about dative bonding, just to make an emphasis, is that one atom contributes or donates two electrons, and the other atom accepts. So what is happening here visually is that we have an atom, if we're looking at orbitals, with a pair of those electrons, atom A, and then there is atom B with an empty orbital ready to receive. So it will donate, and that donation in dative bonding, donation is denoted by an arrow. So we'll see an arrow, and what that simply means is that that arrow pointing from the donor atom to the acceptor. So in this case, looking at the example on top, so we're going to represent this dative bonding like this. So the arrow to show that both electrons came from A and then they were transferred to B. Let's look at examples. I can give an example of 1 NH3 plus hydrogen ion to give us ammonium. So what is happening here is when we look at the visual is we have this and we have two lone pairs there. Then when we look at hydrogen, so we are looking at the hydrogen with an empty orbital. It doesn't have electrons, so those two electrons will then be shared to that, and we're going to have something like this. So to show the dative bonding, I'll just use an arrow there, then we'll have something like that. So this is a hydrogen with an empty orbital, and this is just considering the outermost shell. So we have those two free electrons, so those are the ones that will be shared to that, and then we're going to have this structure. Let's demonstrate another example similar to this. In a case where we have water reacting with H positive, then we get H3O positive. So when we look at water, we have structure like this plus the hydrogen. So what happens is those two electrons now will be shared to that, and then we'll have something like this. Then so if we look at this visually, we are looking at the oxygen bonded to hydrogen, we have that, and then we have those lone pairs, and then there's the hydrogen there which is empty. So those pairs will be transferred to that, and then they'll share by forming something like that. So they'll share. So there we can indicate an arrow to show that it was shared electrons. Lastly, I want to demonstrate what happens in carbon monoxide, which is CO. So in carbon monoxide, both carbon and oxygen donate and accept. So when you look at this structure, you have something like this. If we follow the Lewis, this is 4, O is 1 by 6, so we have 10 valence electrons. 10 valence electrons. So when we use 2 here, minus 2 remain with 8. So the 8 we can put 2 here, 2 there. So what happens in this bonding is that both are able to share and they're able to donate and accept. So this one will do that, that one will do that. So eventually we have a triple bond there, and both are stable. So that is it about the dative bonding. See you in the next video.